Okay, so today, the Ides of March. It is 3/15/19. So my objective today, we're going to be talking about inverse functions. Okay? So we're going to use this symbol, f (-1 of x). Okay, that's my symbol. When you see this f (-1), it means it's the inverse. Okay, that's the symbol for inverse. Okay, when you see that little f inverse or g inverse, but this little (-1) doesn't mean negative exponent. It just means it's the opposite, or it's the inverse. Okay, it doesn't mean negative exponent like our warm up. It just means this is the inverse function. Okay, so you can have an inverse relation. An inverse relation is where you switch all x and y values. But sometimes you can switch x and y values and it's not a function. Okay, I'll show you an easy example. Okay, as an easy example, I could have these points 3, 5, and I could have a point at 1, 5. Now that is a function. These points are functions. Okay, you can have 3 paired up to 5, 1 paired to 5. I mean, if you take a look at a little mini graph of what I just did, if you go 1, 2, 3, 1, 2, 3, 4. Okay, and if I get a point at 3, 5, that's here, and 1, 5 here, that's a function. Okay, it passes the vertical line test, right? But if we did its inverse, yeah, you see it right. So its inverse, you'd have 5, 3, and 5, 1, because I'm switching x's and y's. You with me? So all I did is I switched, instead of 3, 5, I made it 5, 3. Instead of 1, 5, I made it 5, 1. Okay, that's easy. But if I were to graph that, I'd have 5, 3, and 5, 1. So its inverse is not a function because you've got an x value with 2 different y values. It doesn't go along with our definition of an inverse, right? Or of a function. Our function has to have, each x value has to have a unique y. Well, these 5 cups of coffee cost $3. But in Morgan's store, these 5 cups of coffee cost $1. Doesn't make any sense, does it, right? So, yeah, I'm going to Morgan's, exactly. So to be an inverse function, then when you do your inverse is also going to be a function. So to be an inverse function, then you the function and inverse pass the function test. Okay? So the function and the inverse pass the function test. Now what's our function test? Well, one of it's the vertical line test, right? And you can see in this example, the inverse did not pass the vertical line test, or the definition of function, that is, every x value has only one unique y value, right? I can't buy a shirt at JCPenney's, or wherever you want to go, Zoomies or whatever. I can't buy one shirt for 2 different prices. It doesn't make sense, right? You could get a sales price, but then you wouldn't be offered the other price, right? Okay, so example 1. If we graph f of x is 1/3 x plus 6. Okay, I'm going to graph that. I can do this. So I'm going to start at 6, 1, 2, 3, 4, 5, 6. And go down 1/3, down 1/3, right? So forth and so on. Okay. And if I want to graph its inverse, one method is just to take all of its points and switch the points, okay? So one method be say, all right, here's my points at 0, 6. I've got a point at 3, 1, 2, 3, 4, 5, 3, 5. Got a point at 1, 2, 3, 4, 5, 6, 4, right? I've got another point at 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. Okay, so there's just individual coordinates of my function. Now if I want to do its inverse, okay, if I want to do its inverse, then I'm just going to switch the points around. Let's see, I want to find different color. Oh yeah, I got blue, good. Blue, I don't want blue. I can use purple. How about purple? I just want just a different color. So instead of 0, 6, 3, 5, 6, 4, 9, 3, to get its inverse, we're going to switch them around. We're going to make it instead into a, we're looking for a different color. We're going to make it into a 6, 0, 5, 3, 4, 6, and 3, 9. Okay? All right? So I'll go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Oh, hold on. 1, 2, 3. It's obviously Friday. I can't count. 5. 1, 2, 3, 4, 5, 3. There we go. 4. 1, 2, 3, 4. And a 6. 1, 2, 3, 4, 5, 6. And then a 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's up here, okay? There's my inverse. So I'm going to write this as f inverse of x. And the original is just f of x, right? The original is f of x. Okay, not too bad. So to be an inverse, every x and every y are switched, and that's why you've got a line. I didn't do all the points per coordinate, but when I graph the lines, every single point's there, right? When I graph the line, every single point's there. When I graph this line, every single point's there, right? Now, what about the equation of this thing? Okay, if I want the equation, there's two ways to do it. One is to get it from the graph. And I can't, except for that y-intercept's way up here, right? I mean, I can figure it out. I can just kind of make a bigger graph, or I can just keep moving points over. Or, let's get the inverse by switching. Let's switch all of the x's and all the y's. So to get the inverse, let's switch all x's and all y's. Well, to do that, let's just switch the variables, because the x variable represents all of the x's and the y variable represents all of the y's, right? So let's take our f of x and let's rewrite as y equals a negative 1/3 x plus 6. Okay, so here's what we do. We're going to switch the x's and y's. So I'm going to rewrite this as x equals a negative 1/3 y plus 6. Okay, so I just switched, that's all I did, switch the variables. X becomes y becomes x. You guys remember doing this last year or last semester? Okay, now, all we have to do from here is just solve, let's solve for y now, because we need an inverse equation, so let's solve for y. All right, minus 6, right? X minus 6 equals a negative 1/3 y. I'm going to multiply by negative 3. You okay with that? If I multiply by negative 3, does that make sense? If I multiply by negative 3, it would cancel out the negative 1/3. Does that make sense, everybody? Because I would, negative 3 times negative 1/3 would eliminate the negative 1/3, so I multiply this by a negative 3, right? And I'm going to get an answer of a negative 3x plus 18 equals y. Or, since it's the inverse, or, let's rewrite it, or, I mean this is correct, or how about f inverse of x? Because that's, my inverse is equal to negative 3x plus 18, okay? Okay, these are the same answers, but let's write it as an inverse because it is. So let's go f inverse. How am I doing? Am I going too fast or am I okay? Okay, thumbs up. Not too hard, is it? Now, before I move on, though, there is something really unique that I want to show you. An equation, a function, and its inverse are always going to be a reflection over the line y equals x. Always. In fact, if I can kind of visualize this, you know, the barbecue or the skewer, if I were to rotate this like this would flip onto that. Can you see this? This would flip onto that. Can you guys see it? How it would flip? This would flip over here. This would flip over here. So they're a reflection onto each other over the line y equals x. Okay. So it is a reflection. Over the line y equals x. Okay. Awesome. Guys, ready to turn the page? Now, example 2. Let's graph fx equals x squared minus 9. Now, hopefully you guys know it's a parabola. I mean, we've done these before. You guys agree it's a parabola? Let's go down to negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I'm going to advise that you use a pencil and have an eraser because we're going to have to do some work on this one. Okay, we're going to have to get this one to look right. So let me see if I can find a pencil. Oh, wait, I got one right here, don't I? I don't know if I got an eraser. No, that's right. I'll just borrow Callan's. All right, that's not a very good pencil. There's my good pencil. All right, so let's graph this. So it's a parabola, right? And I'm going to go, you know, the easy way for me to do a parabola is a t-table in my head. Over 1, up 1, right? Because 1 squared is 1. Over 2, 2 squared is 1, 2, 3, 4. 3, and I get 9, and then 16. And, of course, it's a parabola, so it's symmetrical, and I get a point here at negative 1, negative 8. I get a point here at, I reflect negative 2, negative 4. And I get another point at negative 3, 0. Okay? How am I doing? And we've done this before, okay? If I graph my parabola in, I get that, okay? How am I doing? So far, so good. There's my parabola. That's easy, okay? So let's get some points. Let me get some points. So the point here is at 3, 0. I've got 2, negative 5. I've got a point at 1, negative 8. I've got a point at 0, negative 9. I've got a point at negative 1, negative 8, negative 8. I've got a point at negative 2, negative 5, and I got a point at negative 3, 0. Okay, these are my points, just any points that are easy points on my parabola. And so if I write those down for f of x, so here's f of x. Let's see what I've got for points. I've got the points, let's start with negative 3, 0. I've got negative 2, negative 5. I've got negative 1, negative 8. I've got a 0, negative 9. I've got a 1, negative 8. I've got a 2, negative 5. And I've got a 3, 0. Okay, how am I doing? What's that, Saul? Move it over. Oh, I'm sorry. Thank you. Thank you, thank you, thank you. Okay, now I just took individual coordinates of my parabola, right? And of course, now to do the inverse, we're just going to switch them, right? So if I want f inverse of x, I'm just going to switch them around. This is, by the way, the least favorite way for me to do it, point by point by point. It's kind of a pain. There's a better way, which I'm going to show you. Okay, so switch them around, right? So I'm going to get instead, I'm going to get a 0, negative 3. I'm going to get a negative 5, negative 2, get a negative 8, negative 1. I'm going to get a negative 9, 0. I'm going to get a negative 8, 1, negative 5, 2, and a 0, 3. Okay, and I'm going to graph those. Now I'm going to be careful. Use a pencil, please. You're going to see why you want to use a pencil just in a second, okay? So, all right, I'm going to graph 0, negative 3. 0, negative 3 is here, okay? Negative 5, 1, 2, 3, 4, 5. Negative 2 is here. Negative 8, 5, 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, negative 9, 0, okay? And I'm just going to do my parabola. It's a sideways parabola is what it turns out to be, doesn't it? It's a sideways parabola, and it looks like this. Now, obviously you see the problem, don't you? Hopefully everybody sees it. But what's the problem?
Yeah.
What is the problem with this sideways parabola?
It's not a function.
It's not a function. You have an x value with two different y values. You have an x value with two different y values. You have an x value with two different y values. It's not a function. So this, as it is, stands, this graph does not have a function. So we can say right off the bat that f of x squared minus 9 has no inverse. I said it wrong. Has no inverse. Has no inverse. Okay, it just doesn't have an inverse. Okay, has no inverse. So what do? No inverse, quit, go home, go away. No, we're going to fix it. We're going to fix it. So let's fix it. So it has no inverse. Let's fix f of x to have an inverse. Okay, well the way I'm going to do that is this. You can take your sideways parabola and you got to get rid of 1/2 of it. So most of the time I'm going to get rid of the negative half because most applications are in positive things, right? You could get rid of the top half. Yes, you can. And it wouldn't be wrong. I'm just going to get rid of the bottom half. So if I erase it, now, if I erase the bottom half of this, just erase it, get rid of the bottom half, okay? And all I have now is just this graph right here. It looks like a square root graph, doesn't it? It is, as a matter of fact, it is a square root graph, okay? Yeah, Daisy?
I solved that.
What's that?
I figured out the square root graph.
Will you hang on to that? Oh, we're going to do that. Nice job. Awesome. Okay, so now, here's the deal. It's a math class, right? And in math class, you have to have rules, okay? Seriously. So I can't just erase the bottom half of this, because if I erase the bottom half of this, then I would have to erase the back half of this, okay? I have to erase the back half of this, because if I keep this side here, it would still fold over to make the bottom half, right? Now think about this. If I keep this part of my original parabola, it would still fold over to make the bottom half of my sideways parabola. So you have to get rid of this part, because if you get rid of this part, it gets rid of the bad part. Now, we can't just erase in math. We have to have a reason. We have to have a rule. So we're going to change. We're going to fix the domain. So let's change the domain of f of x. So to change the domain of f of x, let's take a look at what I just did. Okay? F of x doesn't have, now that I've erased it, does not have any negative value. See that? There's no negative x values. You guys agree? My x values are just positive. So when I changed my domain, I did this. I said, let's make sure that x is greater than or equal to 0. And by saying that one thing right here, we will not graph the negative part of my parabola. So if the negative part of my parabola is not graphed, then the bottom part of the inverse will not be graphed. And what I've done is I've allowed f of x to have an inverse. But I have to have this domain changed. Now, Daisy, what's the equation of f inverse?
I'm pretty sure I did this wrong because I just did the inverse equation.
What'd you get?
I did f of x to the negative 1, so it's the inverse.
Yeah.
Equals the square root of x plus 3. And I'm pretty sure that's...
You're very close. Can we do it? Okay, so let's find the inverse equation. So if I have my y equals x squared minus 9, right? Now if we want to find the inverse, switch, right? Switch x and y, right off the bat. Inverse, so we're going to switch x and y, and I'm going to rewrite this x equals y squared minus 9. How am I doing? Okay, plus 9, right? I get x plus 9 equals y squared. Okay. Square root both sides, right? Square root, square root. How many answers? Square root. 2 answers, right? Now here's the deal. You're going to have plus or minus the square root of x plus 9 equals y. Okay. Now, we don't really want plus or minus because we changed the domain. So it's just plus. Does that make sense? We changed the domain, so it's not the minus. So it's just square root of x plus 9 equals f inverse of x. And you can check that out on your calculator. Actually see it on your calculator. And then days you can't take the square root of 9 because order of operations, you have to add them first.
Oh, okay.
Right? Does that make sense? But you're really close, okay? All right, that's it. Now I do want to look at the journal really quickly because there's some things in the journal that I didn't cover. So let me go ahead and stop recording.